evening, everybody. First, let us solve this problem. Then after, we will go for this source tree RL circuit. We will go for source tree RL circuit. So first, let us discuss this problem. Okay. Now, coming to this problem, here we have two switches. This is a circuit. This is a given circuit. At t is equal to 0. At t is equal to 0, this switch is closed. Okay. At t is equal to 4 seconds, S2 is closed. Okay. So for t less than 0, S1 is open as well as S2 is open. Okay. Then if it is open, if both are in open condition, okay, then what will be the current flowing to this? Okay, what will be the circuit? For t less than 0, what will be the circuit? Circuit will be like this. Okay. Then the switch is open. For t less than 0, both switches are open. That is for t less than 0. For t less than 0, this will be the circuit. Okay, t is equal to 0 minus, the circuit would be like this. Voltage source, resistance, S1 is open, S2 is also open, and inductor behaves as short circuit. Inductor behaves as short circuit. Short circuit. Okay. The current which is flowing through this is I of 0 minus. I of 0 minus. I of 0 minus is 0. So no source is connected to this inductor. Okay. So this instant is t is equal to 0. Okay. This instant is t is equal to 0 minus. Okay. This portion is for t less than 0. This portion is for t greater than 0. Okay. This instant is t is equal to 0 plus. T is equal to 0 plus. Right. For t less than 0, steady state occurs at t is equal to 0 minus. Okay. Steady state occurs at t is equal to 0 minus. At t is equal to 0 minus, steady state occurs for t less than 0. T less than 0. Under steady state DC current, inductor acts as short circuit. Inductor acts as short circuit. So that's why at t is equal to 0 minus, inductor is replaced by short circuit. Inductor is replaced by short circuit. But here no source is connected to this inductor. So I of 0 minus is 0 only. I of 0 minus is 0. Okay. So here inductor opposes the sudden change in current, or current to the inductor cannot change instantaneously. That is, whatever the current is available at t is equal to 0 minus, same current will be available at t is equal to 0 plus. That is, I of 0 minus is equal to I of 0 plus. I of 0 plus. Okay. Because current to the inductor cannot change instantaneously. which is equal to 0 because I of 0 minus is 0. Fine. Yeah, we have to find here. We have to find current through inductor at t is equal to 2 seconds and t is equal to 5 seconds. Okay, so here we have three intervals: t less than or equal to 0, okay, 0 less than or equal to t less than or equal to 4. This is another interval. Okay, next t greater than or equal to 4. We have three intervals. Okay, we have three intervals. Coming to this interval, is 0 less than or equal to t less than or equal to 4. Okay, in this interval, now here we have three intervals: t less than or equal to 0, 0 less than or equal to t less than or equal to 4, t greater than or equal to 4. Okay, so for t less than 0, s1 and s2 are open. Okay, so I of I is equal to 0. That's why I of 0 minus equal to I of 0 plus is equal to I of 0, which is equal to 0 amps. Initial value is 0 because since the inductor current cannot change instantaneously. So let us find response for 0 less than or equal to t less than or equal to 4. Okay, so in order to find the response, okay, 0 less than or equal to t less than or equal to 4. Let us find the response. Okay, so here let us draw the circuit. S1 is closed, S2 is open. Okay, this will be a circuit. Okay, this will be a circuit, right? Okay, the response would be I of t is equal to what? Transient response plus steady state response. That is, we can have a1 e power minus t by tau plus a. Otherwise, you can use this formula. I of t. Otherwise, you can use this formula. I of t is equal to I of infinity plus I of 0 minus I of infinity e power minus t by tau. Okay, so we know the initial value I of 0 is 0. Okay, we have to find I of infinity. Okay, so at t is equal to infinity, at t is equal to infinity, what will be the circuit? T is equal to infinity during this interval. Okay, what will be the circuit? Okay, so the circuit becomes like this. When time approaches infinity, inductor acts as short circuit. Okay, it's 40 volts. 4, 6 ohms. Okay, the current which is flowing to this is I of infinity. Okay, which is equal to 40 by 10, which is equal to 4 amps. Okay, I of infinity is 4 amps. Okay, so which is equal to 4 plus 0 minus 4 e power minus t by tau. Okay, tau is equal to what? Tau is equal to L by R. What is the value of L? L is 5. What is the value of R? R is, what is the total resistance? R is 10. Okay, this is 1 by 2. Okay, 4 minus 4 into e power minus 2t. Okay, this is the expression for I of t during this interval. 0 less than or equal to t less than or equal to 4. You get this. 4 into 1 minus e power minus 2t. Okay, so yeah, here this instant is t is equal to 0. Okay, we derive the expression for I of t during this interval. During this interval, okay, from 0 to 4 seconds. Okay, we have to find the I of t expression for t greater than or equal to 4. Okay, 0 less than or equal to t less than or equal to 4. Okay, this part is done. Okay, let us find this. Okay, we have to find I of t for t greater than or equal to 4. For t greater than or equal to 4. Okay, here this instant is t is equal to 4 seconds. Okay, here s1 is closed at t is equal to 0. At t is equal to 4, s1 is already closed. S1 is already closed. At t is equal to 4, s2 is closed. S2 is closed. Right? Okay. So there will be sudden change in current. There will be sudden change in current in the inductor. Okay. Inductor opposes sudden change in current. So I of 4 minus is equal to I of 4 plus. I of 4 plus, because current in the inductor cannot change instantaneously. See, because you are operating S2. You are operating S2 at t is equal to 4 seconds. You are operating S2 at t is equal to 4 seconds. Okay, so there will be sudden change in current. Okay, so inductor opposes sudden change in current. As inductor opposes sudden change in current, I of 4 minus is equal to I of 4 plus. I of 4 minus is equal to, this instead is I of 4 minus just before the S2 is operated. This instant is I of 4 plus just after the switch is operated. Just after the switch is operated. Okay, so we have to find this value, initial value, in order to find I of t during this interval. Okay, initial value is I of 4 minus. I of 4 minus. Okay, this is initial value during this interval. Okay, this is final value during this interval. Okay, this will be steady state value. This will be steady state value for this interval. 0 less than or equal to t less than or equal to 4. Okay, for this interval, this is steady state value. Okay, so we have to find I of 4 minus. Okay, already we derived the expression for this interval. So let me find I of 4 minus. Okay, this is I of t. Okay, we have this expression. Okay, 4 into 1 minus e power minus 2t. Okay, let us find I of 4 minus. I of 4 minus. Okay, this is the expression for this interval. Okay, 0 less than or equal to t less than or equal to 4, right? Okay, here we have to find I of 4 minus I of 4 minus means, okay, a t is equal to 4 seconds. Okay, you have to put this t is equal to 4 seconds. What will be the current? Okay, so I of 4 is equal to 4 into 1 minus e power minus 8. Okay, which is nearly equal to 4 amps. Which is nearly equal to 4 amps. Okay, so I of 4 minus is equal to 4 amps, which is equal to I of 4 plus I of 4 plus, which is equal to I of 4 I of 4. Okay, this is the initial one. We have got this initial one. In order to find the expression for current for t greater than or equal to 4 seconds. Okay, so we got that value, right? Okay, so for t greater than or equal to 4, okay, we had this I of 4 minus is almost, I think, 4 amps. Okay, now for t greater than or equal to 4, this is closed and this is also closed. This is also closed. Okay, so now let us find final value. Let us find final value. Okay, so here I of t is equal to, okay, I of infinity plus I of 0 initial value plus I of infinity into e power minus t by tau. Here the initial value would be not I of 0, it is I of 4 for this interval. For this interval, okay, initial value is I of 4, I of 4 minus or I of 4. Okay, so this value, right? We have to find this value I of infinity. Okay, so at t is equal to infinity, what will be the circuit? Okay, at t is equal to infinity, this inductor acts as short circuit. Inductor acts as short circuit. Inductor acts as short circuit. Then the current which is flowing through this is I of infinity. Current which is flowing through this is I of infinity. Okay, so you can find I of infinity. Okay, by using KCL, you can find I of infinity. Okay, 40 minus V by 4 plus 10 minus V by 2 is equal to 4 by 6. Let V is the node voltage. Okay, the current which is flowing through this is V by 6. V by 6. Then I of infinity is equal to V by 6. Okay, inductor acts as short circuit, T is equal to infinity. Okay, so final value is 2.72 amps. Okay, so initial value and final value. Let us find time constant. Tau is equal to L by R, L by RTH. If you have more than one resistances, if you have more than one resistance, okay, then we have to find time constant like this. Tau is equal to L by RTH. We have to find Thevenin's resistance. We have to find Thevenin's resistance. Thevenin's resistance between the terminals of the inductor. RTH is the Thevenin's resistance between the terminals of the inductor. Okay, so in order to find Thevenin's resistance, we have to make all sources 0. Making all sources 0 means voltage source is replaced by short circuit, current source is replaced by open circuit. Okay, so let us find RTH between the terminals of the inductor. Okay, between this. Okay, 4, 2, 6. Okay, this is 4, this is 2, this is 6. Okay, between the terminals of the inductor, we have to find RTH. RTH. Okay, so RTH is equal to 4 ohms and 2 ohms. These two are in parallel. Okay, this parallel combination is connected in series with 6 ohm resistance. Okay, so you can find RTH. Okay, 4 ohms and 2 ohms are in parallel plus 6, which is equal to 22 by 3. Okay, you substitute all values. then you get the final expression. Okay, so for t less than or equal to 0, it is 0. It is 0. Current is 0. During this interval, this is the expression for current. Okay, during this interval, this is the expression for current. Okay, so here e power time is calculated from 4 seconds. Okay, so this time would be t minus 4, t minus 4 by tau. Okay, t minus 4 by tau. Okay, t minus 4 by tau. Okay, it is calculated from 0, then e power minus t by tau. Okay, but it is calculated from t is equal to 4 seconds. That's why it is e power minus of t minus 4 by tau. Okay, so we have current expressions. Okay, during 3 intervals. Okay, if you want to here, you have to find current at t is equal to 2 seconds. Current at t is equal to 2 seconds means, okay, that is available during this interval, right? Okay, so you have to at t is equal to 2 seconds means 4 into 1 minus e power minus 2 into 2. Okay, then you'll get current. Okay, t is equal to 4 seconds means you have to go for this expression. Okay, in this expression you have to put t is equal to 5 seconds. T is equal to 5 seconds, you'll get this current. Let us go for next topic. The very next topic is source free RL circuit. Source free RL circuit. Okay, source free RL circuit. Okay, here this is the given circuit. Okay. Now here we have two positions. Okay, position 1 and position 2. Okay, meaning of this is switch is thrown from position 1 to 2 at t is equal to 0. Okay, t is equal to 0. Okay, at t is equal to 0, switch is thrown to position 2. Which is thrown to position 2 from position 1 means for t less than 0, switch is in position 1. Which is in position 1. For t greater than or equal to 0, which is in position 2. Which is in position 2. Okay, so this switch is thrown to position 1 for a long time. Then steady state occurs at t is equal to 0 minus. At t is equal to 0 minus, steady state occurs. Okay, because the switch is in position 1 for a long time. Which is in position 1 for a long time. So steady state occurs at t is equal to 0 minus. T is equal to 0 minus. Okay, at t is equal to 0 minus, inductor acts as short circuit. Inductor acts as short circuit. Inductor acts as short circuit. Inductor acts as short circuit at t is equal to 0 minus. Okay, so at t at t is equal to 0 minus, what will be the circuit? Circuit will be like this. Total resistance, including the resistance of inductor also. R is equal to Ri plus RL. Okay, let me place pure inductor here. Okay, this is the circuit. Sorry, at t is equal to 0 minus, steady state occurs. Steady state occurs. Under steady state DC current, inductor acts as short circuit. Inductor acts as short circuit. Okay, so the current which is flowing through this is I of 0 minus. I of 0 minus. Okay, I of 0 minus is equal to V by R. V by R. V by R. Okay, inductor opposes current changing current. current to the inductor cannot change instantaneously. So I of 0 minus is equal to I of 0 plus is equal to I of 0 is equal to V by R. V by R. V by R. Now the switch is thrown to position 2. Okay. If the switch is thrown to position 2, this will be the circuit. This will be the circuit. Okay. If the switch is thrown to position 2, this will be the circuit. Okay. Means it is source free RL circuit. No source is connected. No source is connected to this circuit. Okay. Here we are going to find expression for current. Okay. In this circuit. In this circuit, we are going to find I of t. We are going to find I of t. Okay. Initially, switch is in position 1. So we have some initial value I of 0 is equal to V by R. That is the initial value. Right. Now the switch is in position 2. Okay. So it is having some energy. Okay. It is having some stored energy. Okay. Because of this initial value. Because of I of 0, it has some initial value. Okay. Some initial value is there. Okay. So it is having initial value I of 0. I of 0 is present in this inductor because inductor stores energy in the form of electromagnetic energy, right? Okay, so it is having some initial value I of 0. Now it is stored inductor. Okay, energy stored inductor. Okay, charged inductor. It is having some energy. Okay. Now we are going to find an expression for I of t. Okay, having initial value. Okay, let inductor is having some initial value I of 0. Okay, because earlier which is in position 1, so this inductor stores some energy. Okay, so it is having some initial value now here. Okay, I of 0 is not 0, not equal to 0. Okay, so what is the expression for I of t with initial value I of 0? Okay, let us apply KVL around this loop. Okay, you apply KVL around this loop, then L di by dt plus R I of t is equal to 0. Okay, the solution of, see, this is homogeneous differential equation. This is not non-homogeneous differential equation. This is homogeneous first order differential equation with constant coefficients. Okay, subjected to initial inductor current. Subjected to initial inductor current. Okay, already some energy is stored in the inductor. Okay, the charge inductor is placed in that circuit. Okay, so here I of 0 minus is equal to I of 0 plus is equal to Vs by R. In this circuit, for this circuit, I of 0 minus is equal to I of 0 plus is equal to Vs by R. Okay, next, as it is homogeneous differential equation, okay, total solution I of t is equal to only natural response. Only natural response, that is In of t, only transient response. Okay, transient response plus steady response will become 0. Okay, ISS of t is equal to 0, will be 0. That will be 0. Okay, because at steady state, at t is equal to infinity, inductor acts as short circuit. Inductor acts as short circuit. When it is acting as short circuit, okay, I of infinity is simply 0 because no source is connected to this circuit. Okay, simply it is 0. So this is 0. So it is having only natural response. Okay, so that natural response is equal to what? A1 into natural response or complementary function is equal to A1 into e power alpha t. Okay, let us find the value of alpha. Okay, you know how to find alpha, right? Okay, from this equation 1. Okay, this is equation 1. You put this is equation 1. You write this is equation 1. From this characteristic equation, okay, where alpha can be found from the characteristic equation of equation 1. Okay, from this you can find L into alpha plus R, okay, into I. is equal to 0. You can find the value of alpha. So okay, so L alpha plus R is equal to 0. Alpha is equal to minus R by L. Okay. So let us find A1. A1 using initial condition. Okay, using initial condition means I of 0. Okay, put I of 0. Okay, then what will you get? I of t is equal to A1 e power minus R by L into t. Okay, so I of 0 is equal to A1 into e power 0 means 1. So A1 is equal to I of 0. So finally the expression will be I of t is equal to I of 0 into e power minus R by L into t. This is the expression. Okay, for current. Okay. In case of source free RL circuit, this is the expression for current. This is the expression for current. Okay. If it is some, you take I of 0 as I naught. I naught. Okay, initial value as I naught, then I naught e power minus R by L into t. R by L into t. Okay. In this case, it is in place of I of 0, you can write Vs by R. Okay. In this case, it is I of t is equal to Vs by R, Vs by R e power minus R by L into t for t greater than or equal to 0. Generally, this will be the expression. Okay. The general expression will be I of t is equal to I of 0 e power minus R by L into t, or I naught into e power minus R by L into t. Okay. If the initial value is given, some value, if some value is given as initial value, then we can use this expression I of t is equal to I of 0 e power minus R by L into t. Okay. For this particular circuit, this is the expression. Okay. Instead of giving circuit like this, see, instead of giving circuit like this, okay, if you have the circuit like this, RL with some initial value I of 0 is equal to some 4 amps. Okay, then we have to use that expression I of t for source free RL circuit. We have to use that expression I of t is equal to I naught or I of 0 e power minus R by L into t. Okay, fine. For the source free circuit, coming to time constant for exponential decay response. Okay, because of this expression Vs by R into e power minus R by L into t, let me have initial value I naught. Otherwise, you can also use that expression I of t is equal to I naught e power minus R by L into t. Okay, here let me use initial value. Let it have some initial value. Okay, instead of writing Vs by R into e power minus R by L into t, okay, let me have some initial value I naught. Okay, so it is having a t is equal to 0 minus steady state occurs. Let it have some initial value. Okay, initially you're going to have some value because of stored energy. Okay, after having circuit like this, okay, source free RL circuit. After having source free RL circuit like this, okay, the energy which is stored in the inductor, starts collapsing. Okay, collapsing and dissipated in the resistor. Starts collapsing and dissipated in the resistor. Okay, it stores energy in the form of electromagnetic energy. So that electromagnetic energy starts collapsing and dissipated in the resistor. Dissipated in the resistor. Okay, that's why you're going to have the expression like this. Okay, slowly current decays. Exponentially, current will be decreasing like this, decreasing, exponentially decreasing, and become zero when time approaches infinity. Okay, so steady state occurs when time approaches infinity. Okay, steady state occurs. Okay, I naught e power minus t by tau. Okay, so after drawing tangent, okay, already we have discussed about this, right? In case of exponentially growth response, okay, in case of exponentially growth response, that is step response of RL circuit. In case of step response of RL circuit, let us draw a tangent like this. Okay, after drawing tangent, okay, this will be t is equal to tau. Okay, because this tangent intersects final value at this time, so that time would be time constant. Okay, here also you can draw tangent like this. Okay, after drawing tangent, okay, you're going to have the time constant like this. This is tau. Okay, at t is equal to tau, you know, right? Tau is equal to L by R. Put t is equal to tau. At t is equal to tau, what will happen? At t is equal to tau, I of t is equal to Vs by R or I naught. Vs by R I naught e power minus 1, which is equal to 0.368 into I naught or what Vs. I naught or Vs. Okay, so you can define time constant like this. It is a time taken by the current. It is a time taken by the response. It is a time taken by the response. Okay, response to fall 36.8% of the initial value. 36.8% of its initial value. Okay, it is a time taken by the response to fall 36.8% of its initial value. Okay, here it is written right. It is the time tau by which the current falls to 36.8% of its initial value. Okay. So with the initial value, you're going to have the expression like this. I of t is equal to I naught e power minus t by tau. Okay. I of 0 is equal to I naught. Okay. You can have the expression like this. Instead of having circuit like that, if I have circuit like this, okay, simply source free RL circuit is given like this. Okay. Without connecting any source, if you have circuit, okay, then if initial value is given, okay, let I of 0 is some value, I of 0 is some value, then you can use this expression here. See, for different values of time constant, okay, this is for t3. T3 you're going to have the response like T2 you're going to have the response like this. Okay, T1 you're going to have the expression like this. The greater is the time constant, the slower will be the response. The slower will be the response. Okay. Now here, see, this is source free RL circuit. Source free RL circuit. Okay. I of 0 is given. I of 0 is given. That is initial value is given. Initial value is given. Okay. No source is connected. Okay. Because here, see, no source is connected. Initial value is given. Initial value means here I of 0 is equal to some 10 amps because of stored energy. I of 0 is 10 amps. Okay, you can use which expression? I of t is equal to I of 0 or I naught into e power minus t by tau. Okay, first let us find, all you need to find is tau, because this is given, I of 0 is given. All you need to find is tau. Tau is equal to L by R, L by RTH, L by RTH. Okay, so you have to find Thevenin's resistance between the terminals of the inductor. Between the terminals of the inductor, you have to find RTH. Okay, so here, how can you find RTH for this circuit? How can you find RTH? Here, dependent source is present. When dependent source is present in the network, okay, let us use test cell. Let us use test cell. Okay, this will be, okay, between the terminals of the inductor. Let me use V test, V test, V test, and this will be 2 ohms, and this will be 4 ohms. Okay, and
class the camera then need to
plus VI. Okay, this is I. Okay, then the current which is going to this is I test. I test. Okay, what will be RTH? RTH is equal to V test by I test. V test by I test. Okay, so otherwise you can solve this circuit by considering V naught is equal to 1 volt instead of V test. Okay, you can use 1 volt. Okay, if you use 1 volt, means what will be RTH? RTH is equal to 1 by I test. 1 by I test. 1 by I test, or here 1 by I naught. 1 by I naught. Okay. So, finally, we can find RTH is equal to V naught by I naught. That is 1 by 2. Applying KVL, you can find RTH. Okay. After finding RTH, you can find tau. Okay. Then I of t is equal to I of 0 e power minus t by tau. Okay. 10 into e power minus 2 by 3 into 2 for t greater than 3. Okay. Okay. Limit. Okay. Now, coming to this circuit. Okay. The switch here, initial value is not given. I of 0 is not given. We have to find this value. We have to find this value. Okay. So the switch in the circuit below is closed for a long time. A t is equal to 0. A t is equal to 0, which has been closed for a long time. Okay. Here, this instant is t is equal to 0, which is opened at t is equal to 0. Here, opening the switch at t is equal to 0 means switch has been closed for a long time. Switch has been closed for a long time means for t less than 0, switch has been closed. Switch has been closed. Here again, we are opening switch at t is equal to 0 means for t greater than 0, for t greater than 0, switch will be open only. This will be open only, right? Right? Fine. Now, in order to find the expression of current for t greater than 0, you should know initial value. That is, I of 0 minus will be the initial value for t greater than 0. A t is equal to 0 minus. A t is equal to 0 minus inductor acts as short circuit. Steady state occurs because steady state occurs. Steady state occurs at t is equal to 0 minus inductor acts as short circuit. Inductor acts as short circuit. Okay. Here switch is closed. Okay. So at t is equal to 0 minus. At t is equal to 0 minus. Yeah. At t is equal to 0 minus. This will be the circuit. This will be the circuit. T equals 0 minus, this will be the circuit. Inductor acts as short circuit. So the current which is flowing through this is I of infinity. The current which is flowing through this is I of infinity. Sorry. Sorry. The current which is flowing through this is I of 0 minus I of 0 minus. Okay, t is equal to 0 minus. This will be the circuit. Okay, which is closed. This is closed. Okay, then you can find the current which is flowing through this inductor. Inductor means when it is acting as short circuit. Okay, t is equal to 0 minus steady state occurs. So inductor acts as short circuit. You can find I of 0 minus the current which is flowing through this 4 ohms. Okay, so finally you'll get what I of 0 minus is equal to 6 amps. I of 0 minus is equal to 6 amps. 6 amps per t less than 0. For t less than 0 or at t is equal to 0 minus. It is the current at t is equal to 0 minus. Okay. Otherwise, you can also have I of 0 minus is equal to 6 amps or I of t. Simply, you can write like this: I of 0 minus is equal to 6 amps or I of t is equal to 6 amps for t less than 0. For t less than 0. Okay, actually it is at t is equal to 0 minus. Okay, but mentioning like this means t less than 0 means here we consider steady state. Here we consider steady state. Okay, actually it is at t is equal to 0 minus. By considering steady state only, will not consider transient state here. Okay, so that's why by considering steady state, we write I of t is equal to 6 amps for t less than 0 instead of writing at t is equal to 0 minus. Okay, we got initial value I of 0 is equal to 6 amps. Okay, now switch is open. Switch is open at t is equal to 0. After opening the switch, that is at t is equal to 0. Otherwise, for t greater than or equal to 0, this will be the circuit. This will be the circuit. Now it is again source free RL circuit. Source free RL circuit. Okay. So you have to find RTH. RTH can be determined between the terminals of the inductor. Between the terminals of the inductor. Okay. So these are in series, and this combination is connected in parallel with 16 ohms. Okay. So you'll get R equivalent RTH. So is equal to L by R. Okay. Then by using this expression I of t is equal to I of 0 e power minus t by tau, then you can find 6 into, you can find this expression I of t is equal to 6 into e power minus 4. And now, yeah, again I of 0 is not given. I of 0 is not given. So we have to find I of 0 means t is equal to 0 minus t is equal to 0 minus, what will be the circuit? See here, this instant is t is equal to 0. This instant is t is equal to 0 minus. This instant is t is equal to 0 plus. Here you are closing the switch. You are closing the switch at t is equal to 0. You are closing the switch at t is equal to 0 means already it has been opened. Already it has been opened for a long time. Okay, for a long time, that is for t less than 0, it has been opened. Okay, because you are closing the switch at t is equal to 0, right? Okay, so the moment when you close the switch at t is equal to 0 means for t greater than 0 also the switch will be closed. Okay, for t greater than 0, right? So in order to find current expression for t greater than 0, I should know initial value. I should find initial value. That is I of 0 minus. I should find I of 0 minus. A t is equal to 0 minus, steady state occurs. Steady state occurs at t is equal to 0 minus. So a t is equal to 0 minus, inductor acts as short circuit. Inductor acts as short circuit. So let us draw the circuit at t is equal to 0 minus. T is equal to 0 minus means switch is open. Switch is open. is the circuit. T is equal to 0 minus, okay, which is open, and this will be the circuit. Inductor acts as short circuit. So the current which is flowing through this is what? I of 0 minus. Okay, it is short circuit, right? So no current will be flowing through this resistance. Okay, so finally, directly you can find I of 0 is equal to 10 by 2 plus 2. Okay, I of t is equal to 2 amps for t less than 0. Or strictly speaking, it is the current at t is equal to 0 minus, but for t less than 0, so during that interval, we consider only steady state response. Okay, that's why I of t is equal to 2 amps for t less than 0. Okay, so you are asked to find V naught for t less than 0. So 3 into I of t, 3 into I of 0 is equal to 3 into 2 is equal to 6 volts. Next, for t greater than or equal to 0, this will be the circuit. Source free RL circuit. Source free RL circuit means you have to use this expression. I of t is equal to I of 0 into e power minus t by tau. Tau is equal to L by RTH. Okay, so you can find RTH between the terminals of the inductor. Then finally you'll get the expression I of 0 e power minus t by tau is equal to 2 into e power minus t by tau. T by tau means tau is equal to 1 second, right? So 2 into e power minus t. Okay, finally you'll get this expression. Expression for current is 2 into e power minus t. Here you are asked to find V naught. Okay, V naught is equal to minus VL. Here voltage at this point with respect to this point is VL. Okay, voltage at this point with respect to this point is minus V naught. So V naught is equal to minus VL. So let us find VL. VL is equal to what? Minus of VL is what? L di by dt. Okay, by using this expression, you can find minus L di by dt minus 2 into minus 2 e power minus t, will get 4 into e power minus t volts for t greater than 0. Okay, coming to I naught. I naught is the current which is flowing through the 6 ohm resistor. Means you know the voltage across inductor, which is nothing but voltage across resistor. Okay, voltage across resistor by resistance. Means VL by 6 expression for current. Okay, so finally we'll get I naught of t is equal to 0 amps. 0 amps for t less than 0. Okay, minus 2 by 3 e power minus t. T less than 0 for t greater than 0. Okay, next V naught of t for t less than 0, it is 6 volts. Okay, and for t greater than 0, it is 4 into e power minus t. Okay, 2 amps. Okay, 2 into e power minus t. See, for t less than 0, I naught is the current which is flowing through the resistance. Here, okay, here for t less than 0, no current flows through this resistance. So I naught is 0 for t less than 0. Okay, you can also find see for t less than 0, we have 6 volts. You can draw a graph. You can draw the waveform. The graph sheet. Okay, I of t, it is having some initial value. Okay, and decreasing, exponential decay. Okay, coming to I naught, it is having initial value of minus 2 by 3. Okay, it is having a t is equal to 0. Okay, I naught of 0 is equal to minus 2 by 3. So start from minus 2 by 3. Okay, from that expression we can draw the graph like this. Okay, this will be I naught of t, and this will be I of t, exponentially decaying. Okay, now, okay, this is the given circuit. Which is thrown to position 2 at t is equal to 0. Which is thrown to position 2 at t is equal to 0. Okay, so here t is equal to 0, which is in position 2. Means for t greater than 0 also, which will be in position 2 only. For t less than 0, which is in position 1. This was in position 1. It was in position 1. Right? Because here you are changing the position of switch from position 1 to 2. Position 1 to 2 at t is equal to 0. Means for t less than 0, which is in position 1. At t is equal to 0, switch will be in position 2. So for t greater than 0 also, switch will be in position 2. Okay. So let us find initial value. Okay. So initial value at t is equal to 0 minus, this is what current, right? Current 10 amps. At t is equal to 0 minus, this will be the circuit. This will be the circuit. The current which is going to say I of 0 minus, Inductor acts as short circuit at t is equal to 0 minus. This is a circuit at t is equal to 0 minus. Inductor acts as short circuit at t is equal to 0 minus. So by using current division rule, you can find the value of current I of 0. IL of 0 minus is equal to 5 amps. IL of 0 minus is equal to 5 amps. Okay. So we got initial value. IL of so current in the inductor cannot change instantaneously. That's why IL of 0 minus is equal to IL of 0 plus, which is equal to 5 amps. Which is equal to 5 amps. Okay. A t is equal to 0 minus, inductor acts as short circuit, then voltage across VL, voltage across inductor is VL. VL of 0 minus will be 0. VL of 0 minus will be 0. Okay. So VL of 0 minus is 0. One cannot say VL of 0 plus is equal to VL of 0 minus. Okay. Voltage across the inductor can change instantaneously, but current to the inductor cannot change instantaneously. So here VL of 0 minus is not equal to VL of 0 plus. Okay. So let us find VL of 0 plus. Okay. If t is equal to 0 plus, what will be the circuit? T is equal to 0 plus, this will be the circuit. 10, 10, 10, 4, 4, current going to be this I of 0 plus, which is equal to 5 amps, which is equal to 5 amps, which is equal to 5 amps. So because I of 0 minus is equal to I of 0 plus, IL of 0 minus is equal to IL of 0 minus is equal to IL of 0 plus, so which is equal to 5 amps. Then you can find VL of 0 plus. VL of 0 plus is voltage at this point, with respect to this point is VL of 0 plus. VL of 0 plus, right? Okay. Current going to this is 5 amps. Okay. Voltage between these 2 points is nothing but VL of 0 plus. Okay. So you apply KVL around this loop plus VL of 0 plus IL of I of 0 plus into 10 plus 10 is equal to 0. Okay, so that we'll get VL of 0 plus is equal to minus 100 volts. Minus 100 volts. VL of 0 plus is equal to minus 100 volts. Okay. So current is flowing like this, right? So voltage at this point, with respect to this point, is 5 into 20, 100 volts. Actually, you have to find voltage at this point with respect to this point, which is equal to minus 100 volts. Okay, so we got VL of 0 plus. So finally, we have to find, d I by di of t by dt at t is equal to 0 plus, which is nothing but VL of 0 plus by L, because VL is equal to LDA by dt. So from this directly, dA of t by dt at t is equal to 0 plus is equal to minus 100 by 4, is equal to 200 amperes per second. Okay, change in current by change in time, amperes per